Good morning, guys. This time, I will review what is SOHCAHTOA because I know some of you couldn't be in my last class. Now, take a look. We have the exercise A and the exercise B. In A, I have a right triangle. How do I know that? Because I know here I have my right angle. Now, if we need to identify the hypotenuse, we know it's the one that is in front of the right angle. So it is the one in red. Same happens in B. I have my right angle right here, so I know that my hypotenuse is right in front. So I know this is my right angle. Now take a look. I'll be using this method in order to get the three basic trigonometric functions for both triangles. Okay, so here are my givens. I have in this right triangle here, I don't know my hypotenuse. I know one of the legs measures 20 and the other measures 18. So the instruction is calculate the hypotenuse and calculate the three basic trigonometric functions, which are sine of the angle, cosine of the angle, and tangent of the angle. So to calculate the hypotenuse, we're going to use the equation that we know as the Pythagorean theorem. So we have hypotenuse is going to be equal to the square root of their legs raised to the second power. So this will be 20 to the second power plus 18 to the second power. Do the math. Square root of 724. Then get the square root of your answer. And voila, my hypotenuse measures 26.91 rounded. Now, knowing this, I wonder, what are the three basic trigonometric functions? But I haven't specified the angle. So what we do is, I will be specifying the angle. In this case, my angle is right here. So my theta angle is right there. Okay, so right now we're going to get the three basic trigonometric functions, and then we're going to calculate how much this angle is. So we know by definition, so is sine of theta equals opposite over the hypotenuse. I know that cosine of theta is adjacent over its hypotenuse. And I know tangent is opposite over the adjacent. Now to get any of the trigonometric functions, we just have to substitute their values. Okay, opposite. My opposite side to the angle theta is the one that is in front, which is 20. So this will be 20 divided by the hypotenuse, that is 26.91. So my answer is 0.74. this is my sine of the angle. Now I will do cos, that is adjacent. Adjacent to the angle is the side, the leg that is touching the angle, that is not the hypotenuse. So it is 18. And the hypotenuse, we just got it, that is 26.91. Do the math. And I got 0.67 rounded. Then I can do the same for tangent, and we have, by definition, opposite divided by adjacent. The opposite to my angle theta is 20 because it is in front. So I have 20 divided by my adjacent, that is the side that touches the angle, which is not the hypotenuse. So it is 18. Do the math. Okay, you have your three basic trigonometric functions. But what if I say I want to calculate my angle? So to calculate the angle in physics, you can use any of them. But in physics, we're going to use the definition of tangent. Okay, so we say that this angle right here is equal to arctangent and 20 divided by 18, opposite over adjacent. So do the math. Remember that in order to get arctangent you have to press shift tan 20 divided by 18, close parenthesis, equal. My angle right there is 48.01 degrees. So I solve my hypotenuse and my angle by using three basic trigonometric functions. Okay, now I'll do the same for triangle B. I can get sine, cosine, and tangent by using the trigonometric functions and using the SOHCAHTOA method that I explained you. Now take a look in this triangle. The theta angle is right here. So first of all, we calculate the hypotenuse because we don't know it. So by definition, we're going to use Pythagorean theorem. So we say hypotenuse equals square root of both legs raised to the second power, 16 to the second power plus 15 raised to the second power. This is the same as having the square root of 481, and then get the square root of your answer and you get 29.93. That's my hypotenuse. So right now I'm gonna use SOHCAHTOA to get the three basic trigonometric functions. So I'm gonna write them. So that tells me sine of the angle equals opposite to the angle divided by hypotenuse. Cos of the angle equals adjacent divided by hypotenuse. And tangent, that is the one that we use in physics to calculate the angle, is opposite divided by hypotenuse. So just plug in the givens. Now opposite to my angle in this triangle, we have, in front of the angle we have 16, and the hypotenuse that we just got, 21.93. Cosine will be adjacent to the angle, the leg that touches the angle, which is not the hypotenuse, 15, divided by hypotenuse, which is 21.93, and the tangent of the angle, I have it is opposite, which is 16, divided by, I have a hypotenuse, but it's adjacent, that is 15. Now take a look right here. Pay attention to this, sorry. So do the math and you get your answers. Okay, I already did the math. Got 0.73 for sine, 68 for cosine, and 1.07 for tangent. Now, as I told you in the exercise before, we use tangent in order to get the angle, because I want to know what, how much it measures. Okay, how wide is that angle open? So it's arctan of 16 divided by 15, and you do the math and you have shift 10, 16 divided by 15, so my angle here is 46.85 rounded degrees. So there you go, you have your hypotenuse right here, your three trigonometric functions, and you have your angle. Let's get into the topic about vectors. Now we're going to use in physics these two main equations to calculate vectors. In case that you have both components, x component and y component, you can get the hypotenuse, or what we know in vectors as the resultant. Also, by knowing both components, you can also get the theta angle. Now let's take a look to this example. We have a vector called d. I know this is a vector because it has a size of 12 kilometers and it has direction. Remember, those are characteristics of a vector. Now in this case, this vector has a name. It's called d. D for displacement. Now the instruction is calculate the components of the vector. So calculate the components means that you tell me what do you have to complete the triangle. Example here, let's say my hypotenuse is the vector and it has that direction, okay? So my components are the green side and the blue leg. So this is what I'm going to get here, the blue and the green legs. How do I get it? Well, first of all, what I always suggest is that you complete your vector by tracing some vertical and horizontal lines. So what I do is I make a dash line here, vertically and horizontally to my vector. There you go. And here I will do the other one in a different color just to show you this. Okay, now you can visualize the components of your vector. You have a vertical component and you have a horizontal component. The horizontal, which is in blue, and the vertical, that is in green. Now you have to tell me, for example, where you have your right angle. Yes, you're right, is exactly here. So as you can see, the hypotenuse is there in front of the right angle. I have 12 kilometers, and that is my vector. So I'm going to calculate in this moment what are my components opposite and adjacent to the angle. So let's see, my opposite component is the one that is over the y-axis. So this is going to be called my y component. Therefore, the one in blue is over the y-axis, so we're going to call it x component. Now take a look. My y component, as it is in front of my angle, I'm going to call it opposite. Remember this? Opposite. And adjacent help us to use trigonometric functions. Now, how do we get the components of a vector? As I have my x component to be adjacent to the angle, my x component will be equal to, as it is adjacent, from SOHCAHTOA I know that between SO and CA, the one that relates adjacent is cosine. So if I want to know my adjacent angle, my adjacent sides, I can use CA to calculate it. So you have this cosine equals adjacent over hypotenuse. If you isolate for adjacent, which is my x component, is going to be hypotenuse times cosine of the angle. Now, do I know the hypotenuse? Yes. I know the hypotenuse is 12 kilometers, and I know my angle, which is 55 degrees. So I do the math. Remember, your calculator must be in degrees. So this will be 12 cos 55, and this gives me an answer of 6.88. Now, remember, we're talking about a leg. This leg is going to be measured in the same units as our vector, so this should be kilometers. So if I want to calculate now my y component, take a look. My y component, how is my y component related to the angle? It's in front. As it is in front, we say this is opposite. And as it is the opposite, we can use SO. Okay, we can use SO to calculate the opposite side. How? By definition, sine of the angle equals opposite over hypotenuse. If you isolate for opposite, hypotenuse goes to the other side to multiply. So you will have your hypotenuse times the sine of the angle. Hypotenuse is the size of your vector, 12 kilometers, times the sine of 55 degrees. This gives me 12 sine 55 gives me 9.83 kilometers. And this, guys, is how you get the components of any vector. I forgot to mention that as a conclusion, we can say that your adjacent component will be equal to vector cosine of the angle, and your opposite component will be equal to vector sine of the angle. Now, in most of the textbooks, they always use x equals r resultant cosine of the angle for x and for y. But it's not always going to be like that. That's why I told you, we always focus on the position of the angle. Because knowing the position of the angle, you know what type of component you are looking for. Thank you.